Welcome back to the channel, everybody. We're out here. You guys are in our market van looking at the greenhouse. We are going to be heading into the greenhouse. We've got our cool solar heating experiment going on inside there, and I want to take some data for everybody. I showed the progress on the experiment and setting it up and getting it running, but now we've got a sunny day. It's about 45 degrees outside, about 80 degrees in the greenhouse. We got both our doors open, venting all that moisture, venting extra heat or excess heat in the greenhouse right now. But tonight we are going to have some cold temperatures, so being able to rebuild that heat or sink it into thermal masses or build little DIY heaters that run off energy from the sun and only energy from the sun. Now, if all that sounds interesting, please consider subscribing to the channel. That's pretty much all we do here. Let's check out our market van. It is wickedly bright out here. So let's check this out here. We've got this market van. Even got the cage up front. This is an old work van I was able to purchase for darn cheap. So I got myself some shelving I had built up in here. Very, very cool to be able to reinvest this money. There is so much room inside this van. We have so much more room than the Dodge truck we were using with a topper and a DIY shelf in it and stuff. Now it may only be about 44, 45 degrees outside, but it's about 75 to 80 in here. It's pretty warm on the ground here too. I'm gonna keep my glasses on. It is super bright outside. Not used to seeing the sun as much as we are. So first off, I want to relate everybody back to the first video where we set up our glycerin and made our own DIY coolant. I didn't actually show making the coolant, but I shared what we have in the coolant and how we made our own DIY coolant that can hold a good freeze. It has a freezing temperature of negative 40 degrees Celsius, which is pretty darn low. So we're able to get way down there before this closed loop system is going to break on it. So that led me to build a system that I could mix some vegetable glycerin. So we've got about 35% glycerin to about 65% water. So the heat capacity of glycerin is not nearly of that of water. So the amount and the ratios did make a difference. So I kind of experimented 50-50 and such and so forth. So I did a bunch of research on it, and I was finding that about 35% is about the perfect ratio of glycerin dissolved in water to give it the lowest freezing point. But there is no highest heat capacity. There is nothing really studied about that. They just tell you what the heat capacity of each is. They don't tell you about the mixtures to get the best heat transfer or the best heat capacity out of your mixture or your coolant. The specific heat of water and the heat capacity of water is about 4.18 joules per gram. And the specific heat of glycerin is much lower, sitting right around 1.25. And this stuff isn't going to burn or boil on us. It's got an ignition of about 370 degrees Celsius. So this glycerin's pretty darn safe. It's not going to just combust or anything like that. And it's decent to work with under pressure. So that all being said, my biggest concern for the system was just not having it freeze. So everybody's seen the videos with a closed loop system hooked up to a radiator inside a window and it just busts. Everything busts out. We've had that happen. We've experimented with stuff like that and it always does freeze up and break. So in order to save our investment of this little heater, I decided to go with a DIY coolant so it can just flow on a closed system. So enough about that. Let's take some temperatures from this system and see. So first of all, let's just take a temp of the window itself. Okay, so that window holding like 99 degrees or something like that. Yeah, it says 99 there. And let's just take a temp of the soil. So the soil right in front of it that is in the sun is sitting 72 degrees. Soil behind it that's actually heated up by the water behind it, 72, 71. Cooler in the sun, it's about 82, 77. The bricks, this is all in sun, but this is an open window right here from our little window opener, the actuator opening it from high temperatures. So just wanted to give a roundabout to show what all the temps are from the sun shining in here, all the same as it shines right onto that little sandbox. So let's go ahead and kick this bad boy on. So our temperatures are going up. I can feel warm air coming off. We're holding about 86 in the system here. So So about 86 is what we're throwing off of the whole system as a whole. And that's a lot warmer than the actual temperatures that we're holding on the floor in here. We're actually absorbing quite a bit more. Some passing clouds and stuff, and that's the kind of temperatures we've built to the half point of the day. We will build more temperatures later into the night, and then that box running on a timer, running this for 15 minutes, we'll get a little bit of longevity in the night for a couple hours at least, and we'll be able to pull some decently warm temperatures off of this. I could feel the heat radiating off of these fans, and it was blowing it past me. Now, putting it in a situation where we've got all these crops over here for our farmers market, we've always got to start a ton of plants late winter, early spring, so having a little hoop or a tunnel system for all of those crops, and if I could blow some type of heater system through that little tunnel, I could keep a lot of warm temperatures and heat up all of those little crops that need that extra heat at nighttime, or a little bit of extra heat to get germinated. Now, this system has been a long time coming. I really wanted to get this up and get it running. Even though we're at the end of winter here, we're still in need of a little bit of heat here and there. Being able to get this operating, and then I can just take it down when I don't need it, keep it in a box, pull it back out next winter, and have this operate for me and hold a lot of energy in that sand overnight, and then I can slowly pull that energy off into tunnels or into thermal masses. And I could also do this with a closed loop system where I run a whole bunch of water heating throughout the entire greenhouse using the sun. So this is just the first steps, and this is basically just experimental. I'm going to do a little more experimenting with this system before it gets too warm on us. I take it down, and then we can use all of these little components next year. All of the investment we got here will be able to be reused. So if anybody's got any questions, this was the data part. I just wanted to show how it was heating and what it's actually doing. We're sitting 44 degrees outside and about 80 degrees in the greenhouse at the very, very top. And the floor of the greenhouse is about 70, 71, 72 in the sun. So being able to pull higher temperatures than that out of this box and through the system and then back out into the air is pretty darn cool. So hopefully everybody found this as interesting as I did, and we will continue experimenting with this, and there'll be a whole bunch more on this guy next winter.